We are physicists from Group 1, Awesome 2.0. So we're going to present about Rutherford gold foil experiment. Okay, before that, we're going to introduce ourselves.
Hello, my name is Muhammad Azam. Oh, hello, my name is Muhammad Fuad.
Yeah, and I'm is Muhammad Mirzan Mer bin Rahim.
And I am Muhammad Hafizat Shah.
And I am Saiful Amri bin Rosali. So, now we're going to story about the classical atomic model. First, that is discovered by J.J. Thompson. So, let's go. Check it out.
Now we are proceed to the atomic model by J.J. Thompson. Okay. In Thompson's atomic model, Thompson proposed that the atom is composed of electrons surrounded by a soup of positive charge to balance the electrons' negative charge. So, in J.J. Thompson's, who discovered electron in 1897, proposed the plum-pudding model of the atom in 1904, before the discovery of atomic nucleus by Rutherford. So in Thompson model, the atom is composed of electrons surrounded by a soup of positive charge to balance the electrons' negative charge. Like negatively charged is the plums, surrounded by the positive charge, the pudding. So in 1904, Thompson's model was disproved by the Rutherford. Okay, that's all. So just now we have explained about the J.J. Thompson atomic model. So right now we are going to the Rutherford atomic model. So check it out.
Awesome.
After J.J. Thompson exposed his new atomic model in 1904, Rutherford discovered a new atomic model. Rutherford then developed the planetary model of the atom, which put all the protons in the nucleus and the electrons orbited around the nucleus like planets around the sun.
And now we will discuss about the implications of Rutherford's gold foil experiment in modern physics. Check it out. Check it out. Awesome.
A good way to investigate the structure of a microscopic system that is too small to observe directly is to say that in the fast moving charged particle into the system, and then look at this charged particle as they come out of the system. Rutherford used a newly discovered alpha particles coming out of the radioactive material. The experimental setup is like this. The alpha particle can only come out of this plug to the narrow gap over here. Then the lead go to the slit hit a very thin gold foil. The system's radicals is green all the way around.
The screen was coated with fluorescent materials, so it lights up every time an outgoing alpha particles hit the screen. What Rutherford found out was that most of the alpha particles pass through the foil unaffected, as if the foil was not there, only about 1 out of the 8,000 the alpha particles was deflected at a very large angle, some even nearly back in the direction in which they had come. This experimental result led Ernest Rutherford to publish his planetary model or nuclear model of an atom in 1911. He proposed that an atom has a structure similar to that of the solar system. The nucleus is like the sun, and the electron orbit around the nucleus, like the planet orbits around the sun.
He said that because the most of the alpha particle went through the foil unaffected, the atom must mostly consist of empty space, just like our solar system. It was how at the time that alpha particles are positive charged and each has a mass about 7,300 times that are being an electron. It was found that later that alpha particles are helium nuclei because when this very field alpha particle has the nuclei and get deflected, as they tend to bounce back at large angles. And because alpha particles are much heavier than electrons, this means that the nuclei must be even heavier. And because the alpha particle did not pull in by the nuclei must be positively charged.
So, Rutherford said that an atom has a nucleus, and the nucleus is positive and has over 99.9% of the mass of the atom, and the atom is mostly empty space with the electron orbit around the nucleus. Everything seems perfect fit because the attractive electric fields between the negatively charged electron and positively charged the nucleus is what's needed to provide repellent force to keep the electron circular motion. The only thing is that the scientists already knew that an accelerating change gives short electromagnetic radiation. This means the orbiting electron with centripetal acceleration will lose energy to a radiation spiral inward, and plunging into the nucleus in a small fraction of a second. In fact, it's about 2 in 10 to the negative 90th of a second.
The atom in Rutherford model are very unstable, which contradicts to observe disability of atom in nature. Even if we ignore the disability problem, the Rutherford model is still lacking in the explanation of the discrete light spectrum produced by atom, because when electrons spiral toward its orbital frequency will increase continuously, which causes the electromagnetic wave given off by the electron to increase in frequency as well, thereby producing a continuous spectrum instead of a discrete line.
Okay, that's all from us. Hope you enjoy our video. Please subscribe us and that's all from us. Okay, thank you. Bye. Awesome.
Enjoy our video, and hopefully you guys hit the subscribe button at the top. Okay, thank you, bye.